Hi everyone. Today I'm going to show how to analyze bivariate data using Geogebra. So I'm using Geogebra here as an application in a browser window. So I start the calculator and most of what is here is great, but there's a little choice up here where I can use Geogebra Classic. That's pretty important for what I'm doing today because once I have the Classic view, I can then view a spreadsheet. And this is where I will input my raw data. So I've got a set of data here. So the this is the number of PhDs in engineering that were awarded each year. And then I had the consumption of mozzarella cheese per capita. So in the year 2000, 480 engineering PhDs were awarded, and there were 9.3 pounds of mozzarella cheese consumed per person. Now, I'm just going to pause while I enter the rest of. Okay, so I've got that data entered. So this was the year 2000 all the way down to the year 2009. So as you can see, each year there was a different number of engineering PhDs awarded, and there was a different per capita consumption of mozzarella cheese. So the what you want to do is highlight the numbers only, and then on the menu over here at the left, you want to create a list of points. Now you get to name this. You can call it anything you like. I'll call it list one. It's a good idea not to have spaces in the name, and we'll say OK. Now I don't need the spreadsheet on view anymore, so I'll just untick spreadsheet. And you can start to see my data points are clustering here. Now that's a pretty good looking scatter graph. There seems to be definitely some sort of a correlation going on. Now just remember, just because there's a correlation doesn't mean there's actually a cause and effect going on here. The increase in the number of PhDs doesn't have any link whatsoever, any cause about why people ate more mozzarella cheese. So sometimes there can be correlation without causation. That's an important thing to remember. But there's definitely an association going on, and it would seem to be a positive association because it's rising, and it would seem to be reasonably strong. Now, I can fit a line to this, and the command to type is fit line. Then we open brackets and we give it the list of points, which was named list one. And there we go. So that's the regression line, or the least squares, or the line of best fit. And there's the equation for my line. So a very, very low gradient and an intercept of 6.599. So that's how we find the least squares, or the best fit line, using GeoGebra on a scatter graph. I can do a few more things here as well. I can use the command r². Now, in this case, I have to give it the list of points, list one. Then I have to tell it the function to compare to. So it's function f. So I put an f there. And I've got an r² value. That's the proper name is the coefficient of determination. That is 0.919. So that means that the change in the x coordinate, the number of PhDs awarded each year, had a almost 92% of that change explained the change in the consumption of mozzarella cheese. Remember, there is an association here that's quite strong, but it doesn't necessarily mean there's a cause effect going on. Correlation can occur just by accident, and that's what's happened here. So that's how we use GeoGebra to make a scatter graph, to insert a line of best fit, and then to calculate out here the correlation coefficient. I could use this to interpolate or extrapolate. Just imagine I was interested in how much mozzarella cheese would be consumed if 600 PhDs were awarded. So it would be the value here on the line. So you see my formula here, it's a function f. I think I can just type f brackets 600, and you see it gives me the answer 10.1. So if I was to run up there at 600, then that is 10.1. So I can use this to calculate or make predictions. Remember, this would be an interpolation. The number 600 here on the horizontal or the explanatory variable, 600 is within the set of observations. That's interpolation. I could also extrapolate. I could say, what happens if 800 PhDs were awarded? How much mozzarella would be consumed? So I could literally go F800 on the, now that's 800 is beyond the observations. So this is an extrapolation. If 800 PhDs were awarded 1 year, we would predict that 11.3, approximately 11.3 pounds of mozzarella cheese would be consumed by every person. Uh, that's a bit of a silly conclusion because there is no causal link between numbers of PhDs in engineering and consumption of mozzarella cheese. But it's still just demonstrating how we would use the software to do this. All right, then that's it for this time. Thanks for watching.